Okay, so here's my data. I changed the mass of the pendulum, and I left the length constant at 32 centimeters, and I measured out some of these trials for the period. I only did 3 trials on some of the masses, and then I did 2 on other ones because I know that you guys didn't get all the data. So just as a reminder, the way to find the average of the period is to add up each of these and divide it by however many you have. So I added these 3, and then you divide by 3 to get your average. If you only have 2 sets of data, I had to move my decimal, so don't worry about those mistakes. You add them up and you would divide by 2. All right, so here are all of my averages for the period with changing the mass. All right, so here's how you would make the graph. Graph 1, I checked in your lab books, and you have a graph similar to this. It's very faded, so it's hard to see, but they do have these little cross marks, which is nice because that gives you 5 boxes. So it's a good visual to have, but not all graph paper has that. So what we're going to do is I'm going to show you how to create a graph for the mass. All right, move it down. There we go. So you were changing the mass, and you were measuring the period over here. So the one that you change goes on the lower axis or the x-axis, and so what you're going to do is just draw a line. We're going to label this mass, leave a little bit of space because you need to put the numbers in here, and we were measuring it in grams. So make sure, oh, you can't see that, can you? There it is. So label it mass, leave a little space for numbers, and put your units. On the side axis, which is the y-axis, that is where you're going to put the variable that you measured. It's called the independent variable. And we were measuring the period of the pendulum, so we'll put period like this, and make sure you include S for the units, seconds. All right, and then the title up the top, it's going to be the independent versus the dependent down here. So you would just write period versus mass, and that's going to be the title. Sorry about all these shadows. I don't have great lighting, but I'll let you see it when I'm done writing it. Period versus mass. So what is the period as we change the amount of mass? So that's how you title the graph. Okay, now we're ready to plot our points. Nope, we got to make our scale first. Okay, so my largest value for mass was 75.3. That's pretty close. I might just go multiples of 5. No, okay, I'm going to go by hundreds. So I'm going to do 25, 50, 75, and get my 100 out here on this edge of the graph. And I chose that just because I know I can easily divide it by 5 since we have these 5 boxes here. So I'll label this 25, 50, 75, and 100. And then 0 is here. All right, and up the side, my period, I have 1.10, 1.11, 1.12. So those are all very similar. In fact, they're pretty much the same number. And so I want up here, let's say if I go 0.51, it's kind of small. I'm just trying to do this in my head real quick. I guess I'll put it right here. I'm going to say this is 1.5 on mine. You can do something very similar. We'll say this is 1.0. This is 0.5, and then we have 0 down here. So again, I went by multiples of 5. This would be 0.1, 0.2, 0.3, 0.4, and so on and so forth. All right, so that's how we can set up the scale for this axis, or for this graph. All right, now I can plot my points. So I had the mass of 26.3, so I'm going to go just a little bit past 26 or 25, so it's going to be somewhere right here. And then 1.1 for my period. So I'll go up from that point here up to 1.1, which is right about there, and I'll plot that point, make it nice and dark. All right, next one was only almost 40 grams, 38.8. So I will say 40 would be 30, 35, 40, right about here somewhere. And I'm going to go up from there to 1.11, which is almost about the same thing. So that would be right about here. And then I have 51.4 as my next. So that's just a little past the 50. And that's also a 1.11 or 1.11. 63.8 for that mass. I'm going to go 60 would be here. That would be 65. So that's right about there in the middle, 63.8. and a 1.12. So that is just about here. And then my last one is 75.3. So just pretty much right on the 75, and I go up to 1.11. Oh, look at that. Our eyes are really good at picking up patterns when we see them. So this looks like a pretty straight line. And what that means to me, I'm going to sketch out my best fit line, something like that. What that tells us is that as we change the mass, this value down here, we have no change in the period. It stays the same the whole time. All right, this is getting a little bit lengthy, so I'm going to try and move along quickly. And maybe what I should do is I'm just going to fold this in half real quick so I have more room. All right, on to graph number 2. And now what we're doing is I kept the same mass, 26.3 grams, and I changed the length. So I did 10, 20, 40, 60, 80, and an extra one. I couldn't quite get 100, so I just went with 98 because my pendulum was hitting the bottom. All right, so I actually did 6 trials on this one, and then I only took 2 sets of data for those. I ignored the third trial, and then I averaged 2 of them. So those are my numbers that I'm going to be plotting. Okay, so again, create your axes, the x-axis or the independent variable down here. Nope, doing it off camera again. Well, what was I changing? I was changing the length. So I'll label length, and that was in centimeters. And then on the y-axis, the dependent variable. Did I say that wrong on the last one? This is definitely independent variable, and this is the dependent. This is the one that you changed, or the one, I'm sorry, this is the one you changed here. This is the one we measured, period, in seconds. Okay, and so again, if I were to label this, it's going to be this period versus length for the title. Period versus length. Oh, I wish I could spell length. Right, just like that. Put the title up near the top. Okay, and let's take a look at my data. So my biggest number here is about 100, so I can pretty much use the same scale. If I say 25, 50, 75, 100 all the way out here, and I'll go 0, 25, 50, 75. Another thing you could do is you could go by 20s if you want, because you did your changes were 20, 40, 60, 80, and 100. You could go by 20, 40, 60, 80, and 100 like that. And then you would be able to stay right on the lines. I probably should have done that, but that's okay. All right, and then my largest number here was almost 2. So I'm just thinking that's pretty close to 2. So what I want to do is I want to put, I'm going to see, let's see if there's a 0.5. I might put the 2 right up at the very top there. Say this is 2. So that would make this one a 1. And here's my 0, right? See how I split that up evenly? And then I could put the halves in between. So this would be 0.5, and this would be 1.5. So you can make your graph pretty much the same. You could do your same axes as what I just did. All right, so let's go start plotting points now. When I had a length of 10 centimeters, I had 0.57. So 10 centimeters would be right on this. So that's my 10. And what did I say it was? 0.57. So that would be right about here, I think. Right. The next one, when I changed the length to 20, I had 0.87. So 20 would be here, and then 0.87 would put me way up here, like right about there. Okay. 40 was 1 1/4. 25, 30, 35, 40 would be there. And that was 1.25. So 1 over here. 0.1, 0.25. So right there-ish. Okay, last, closing in here. We're halfway done. 60 to 1.54. So at 60, which for mine is, oh, let me do it right there. That's my 60. I'm going to go up to 1.54 from there. So 1.5 is way over here, and I'll go up a little bit beyond that, right about there. Okay, 80, 1.77. 80 would be here, counting by 5s on my boxes, and 1.77 goes way up. So this is my 1.5, 1.6, 1.7, almost to 1.8, but we'll put it right here. And then lastly, almost 100 was 98. I had 1.95. So just shy of 100 here. I'll put it just left of the lines. 1.95, really close to 2 up here. So you just have to match those up. I'm just going to put it right about there-ish. Okay, so if we look at these, do you see, oh, and if there is no length, if we have 0 length of my pendulum, we're not going to have any period. So let's put that in there, even though I didn't put it in my data. 0 and 0. There, now it is. Okay, so look at this. Does this look like a straight line? Not really. It looks more like a curve. So what we're going to do is do our best freehand. Try and connect all the dots as best you can. Hey, that turned out pretty good. Proud of myself. Okay, so your graphs should look like that, where we had for the mass, we didn't see any change in the period, straight line like that. And as we changed our length, we got a corresponding change in the period. It kind of has this curved shape to it. All right, so that's how you do the graphs for this lab.